Let's begin. Okay, so we're going to tie in everything we've learnt so far. Let's remind ourselves. So for parallel and perpendicular lines, they still follow the general linear equation. When you think of a linear equation, this is a linear equation. So y equals mx plus c. You type that into Desmos, make up a number for m, make a number for c, because those are your parameters, and it will sketch a straight line, no matter what number you pick. Okay, it could be negative, could be decimals, could be roots. Does not matter. You can even put fractions with roots and decimals in them. And as long as you've got one x and one y, it should turn out to be a linear straight line. Okay? So let's remind ourselves. What is m again? Can I please have? Let's go Raphael.
M is the gradient.
M is the gradient. Very good. The definition of gradient is equal to what? Let's go with... Thank you. I've frozen the screen, and then let's unfreeze. Oh yeah, so m is the gradient, and it equals, what's the definition, Andrea? Rise over run. So this is what you would have learned back in year 8 if they did get to it. Rise over run, and then after you learn rise and run, which is really just how far vertically do you go, in ratio with how far horizontally you go. That's the only way to draw a diagonal line, right? So a diagonal line always has a horizontal distance, and then it also has a vertical distance. Okay, so that's what gradient really represents. It's just the ratio. That's why it doesn't matter which 2 points you pick, because you're talking about a ratio. So rise over run then gives you this formula, which a lot of students memorize, but really it's very logical. But let's see if you remember the rules. Someone else, you know. Very good. So usually with the mainstream class that I normally teach, I just tell them to memorize it. You guys, I do try to explain that that is the distance vertically, and that's the distance horizontally between 2 points. Okay, so it's just like final minus initial, final minus initial. That's it, yeah? But then I also then pushed your understanding a bit. You didn't have to know this. This is just the third formula. If you got it, great. But you'll definitely see it at year 11 methods. Anyone remember the last one that involves an angle? Tan of an angle. So on your calculator, if you type tan of whatever angle you come up with, so this is 0 degrees. That's by convention, that's 0 degrees. If I went up by 20 degrees and you type tan of 20, whatever the calculator says, that is the gradient. That's m. That's what it equals to. So every time you type on your calculator, it's telling you m of that straight line. Okay? All right, so those are the three things, but really at your year 9 level, you don't need that. Cool? Or if you have the graph, you just look at it and count, rise over run. Let's go to C then. What does C stand for? Let's go with someone else again. Let's go with Emma. Y-intercept. It is the y-intercept. How do you find the y-intercept, Sean? That's true.
Sorry, you said y to 0 and you find x.
It's the other way around.
The other way around.
The other way around, because we know on the y-axis, and if you ever forget how to find the y-intercept, think about the y-axis. If I picked a point and I said this was 3, and I asked you to label the coordinates, what would the coordinates be? And then you would naturally then write 0, 3, and clearly x is 0, y is 3, so hence x is always 0, and we don't know what y is. Okay, but in that case, C is your y-intercept. Good? So here, just to write a note if you didn't know, it's let x equal to 0 to solve for it. Great. Now, you still need these. The only difference today I'm teaching you is this bit. Okay, so the gradient, when it's parallel and perpendicular, there's something special about it. And that's the only thing you changed. But to find this is still exactly the same as what you've been doing in all the other exercises. So, here, we know that perpendicular lines cross at... What's the degree? Anyone know? Do you know what perpendicular lines mean, actually? Right angles. Okay, so you can have right angles or 90 degrees. So right here, 90 degrees. So they cross at 90 degrees, whilst parallel lines, do they ever cross? They don't cross. So this is key. Let's draw the picture. Oh, and you can actually draw this symbol when you want to say one line is perpendicular to another. So you can say something like this. you can say equation y1 is perpendicular to equation y2. That's just a short way. In mathematics, if you draw that symbol, mathematicians will know that you're trying to say that those two are perpendicular to each other. Okay? So, with perpendicular lines, I'm just going to draw it again. You have two lines, and there, actually, I should do it like this, so it's nice and straight. There we go. Maybe 90 is about there. So, when they intersect at 90 degrees, there is something special about the two gradients, which later on I'll do the proof, but at the moment I'm just going to get you to think about it. And then, if they are parallel, there's also something special. Parallel is easier to figure out. So remember I said the only thing I'm going to change today is the gradient. So let's look at two parallel lines. You told me the gradient is the diagonal line. It's by a ratio of how much you go across and how much you go up, and this is the formula for it. So when you talk about parallel lines, this has a horizontal distance, has a vertical distance. This also has a horizontal distance and a vertical distance. But what can you logically decipher about two parallel lines in terms of their gradients? What's special? Yeah, that's one of the biggest things that is a state, and it's a property that I keep telling my year 11s, but it's for them, they're memorizing it, but they're not understanding it. Two parallel lines, if you type on Desmos right now, so if I go to Desmos, I love Desmos. It's so easy to visualize. If I type in an equation and I said, actually I'll just do it on this keyboard, it's easier. Y is equal to 2x minus 1. There we go. That's a gradient of 2. That's the steepness of 2. Minus 1 tells me the y-intercept crosses at 1. So you can see if I zoom in over here, it's minus 1. Right? Now if I type a second equation, you'll see here that if I type exactly the same gradient, just 2x, they're going to be parallel. Just straight off the bat, they're already parallel. Okay, and the y-intercept, clearly I didn't put anything, so hence it crosses at 0. But if I put in a y-intercept, I can put in any y-intercept I want. Point is, they're always going to be parallel. Okay? Now, all I need to do to make sure that they're not going to not be parallel, is as long as I change the gradient. Now I can change the gradient to 5, and it becomes very obvious. Yeah, sure. I don't have tissue. Yeah. All right, so you can see gradient of 5 tells me that I go up by 5, because 5 as a fraction is 5 over 1. So up by 5, 1 across. That's why the blue line is steep. So if it's steep, eventually it's going to intersect. Okay, so that's one of the things we know about parallel lines. As long as the gradients are the same, they're never going to cross. And that's special. Okay, so that's special for us to be able to decipher. So, let's have a look back at our notes. I want you to write in, when you draw out your two parallel lines on a graph, one of the properties that we know is the gradient. Let's call this y1. So that's gradient of the first line, and then that's the y-intercept of the first line. y2 is the equation of the second line, gradient of the second line, and then y-intercept of the second line. What we know is that m1 and m2 must equal to each other. That's a property. So m1 equals m2. And that's what I've got just underneath here for you. When two lines are parallel, then m1 equals m2. That's what I'm trying to say. Okay? For the other one, you're going to memorize this, but I believe once you've gotten used to this, I want you to sit back and have a think. Why is that true? And whether you can prove that. Because you can prove it if you just make up some coordinates. Let's call AB and then BA, for example. Or you could choose, if you're not used to using abstract thinking, you can choose two coordinates that are easy to think. So like 1, 1. 1, 1, and then if you had to do a perpendicular line to it, where would the next coordinate be? If you want to think it that way, you can actually prove why that property is true. Okay? But for now, for the other one, when it's perpendicular, when you have two lines that cross each other at 90 degrees, one of the properties that we know is the gradient of the first line, so m1 versus times the gradient of the second line. So m1 times m2 will equal to negative 1. An alternative formula that students like at year 11 is this. If you rearrange this one, so if you know the gradient of one line, you can definitely figure out the perpendicular gradient of the second line. Okay? So what they like is this is an alternative formula that you can write down if you like. M2 is equal to negative 1 divided by M1. Most students tend to memorize this one. I like this property because that's where you can prove. You can prove it easier. Okay? So let's do some examples now. So you got the theory. The only thing I'm changing today is the gradient, but only in two special cases, when you know the two lines are perpendicular and you know the two lines are parallel. And so we don't have to technically do y2 minus y1 sometimes. We just use these two properties to figure out what your gradient is. Okay? So there's two formulas there, or properties. M1 equals M2 is your parallel, and then M1 times M2 equals negative 1. That's your perpendicular. If you like a third one, I'm just rearranging it. Divide both sides by M1. That's why M2 equals negative 1 on M1. Okay? All right. Let's have a look. Let's have a look at this example here. This is a first line, so let's call that Y1. This is gradient of the first one, and then this is the y-intercept of the first one. So this is M1, C1, and Y1, right? If I want them to be perpendicular, the only thing I have to make sure is the gradient M1 times with the gradient of the second line. Doesn't matter about the y-intercept. Who cares about that? We just care about the gradient. M1 times M2 needs to equal to negative 1. And you start to see a pattern here. And you see that when M1 is negative 4 times 1/4, because 1/4 of 4 is 1, and that's a negative, then that has to be positive. So it's really just the reciprocal of whatever this number is, and then the different sign or opposite sign. So if I gave you a different equation, I said, I want you to write an equation that when you type in Desmos, it's going to be perpendicular, you should be able to figure it out very quickly. Let's say I give you this. Let's say I give you 3x plus 2. So this is y1. What would the gradient of the second one need to be in order for them to be perpendicular? Have a think. Right. Yeah, negative 1 over 3. And we can prove that. Type it on Desmos. And I don't care. I just made up the y-intercept, so 2 and 1. But as long as the gradients, you see I said that's a 3, so the reciprocal of 3 is 1 over 3. But that's a positive, so just make sure you have a negative. So I'll just make the negative a bit clearer. Make sure that you have a negative, and it's reciprocal. Those two will be perpendicular. Okay? So that's going to be the first step that you're going to be working with, and you'll find that it's easy to figure out. Let's say parallel instead. These two equations, they are parallel. I just wrote it differently. This one has a gradient m1 of negative 1, because the number in front of x, even though we don't write it, it's 1. So that's negative 1 there. Now, if these two have to be parallel, then that means the gradients have to be the same. Notice this is not in the general form, general linear equation form, so I have to rearrange it. How do I rearrange it? Remove that x. Now, if that's a plus x, the opposite of plus x is minus x. So if I minus x on both sides, I will now get y is equal to negative x and a positive 5 there. And you can see there, that's a negative x, so the gradient's negative 1. This is a negative x, and the gradient's also negative 1. And I will guarantee that they will be parallel. Just like I showed you in Desmos before, they have a different y-intercept, but they have the same slope. So if I gave you an example, if I told you that y1 was negative 1/5 x plus 7, and I wanted the second line, I want the second line to be parallel. and I'm going to make up the y-intercept, let's say plus 8, what must the gradient be in this case? What's the number in front of x? Yeah, negative 1 over 5. That's it. This is just the two properties that I'm teaching today, but I'm telling you, it just goes all the way up to year 11. So they learn in year 9, they learn in year 10, and then they learn it in year 11. And this is still the one I keep revising. So at the start of this year, term 1, I had the first week, I was revising again with my year 11 method students these two properties. It's a very logical property, but when I ask them, they'll forget, they don't know how to do it, and then I had to show them the problems that you're about to do on the next page. So what we're doing here is an example of what you're going to do the first week of the year 11 methods. Yeah? So here we go. Let's go to this one. So this is the kind of question I gave to them. Find the equation of a line. So as soon as they see that, you should be thinking, okay, I need y equals mx plus c. I don't know what the equation of a line is, right? I know I need to find m, I need to find c. But what do they tell me? This line is going to be parallel to this line. So that's a key thing. I know these two lines need to be parallel. And I also know it passes through 1, 5. Okay? So what that means is, if I know that x is 1, then the y coordinate must be 5. That's it. Okay? Let's solve for this. We can definitely figure out m already just based on the fact that they said it's parallel. What must m be equal to? Can I please have Rowan? Negative 3, because they said parallel. These two lines, if I want them to be parallel, they need to have the same gradient. Parallel means m1 equals m2. Well, since this is m1, the first one that I've got, it's negative 3, well then m2 must be negative 3 too. So the only thing I don't know now is I've got y equals negative 3x, so that guarantees it's going to be parallel. The only problem is I don't know what c is. That's the equation of the first line. That's the second line I'm trying to figure out. Negative 3x plus c. So how do I find c? Just going all the way back to what you did in exercise 1F. What do you do? Yeah, because that's the only other thing we know about this line. This line is parallel to this, and it also passes through 1, 5. What are they saying? They're saying, whatever rule you've come up with, if you have x is 1, the result of y will be 5. So all it means is, well, if x was 1, negative 3 times 1 plus whatever this number is must equal to 5. That's all it's saying. So let's solve for it. 5 is equal to negative 3 times 1 plus c. 5 equals to negative 3 plus c. It's all right, just grab a seat, and there should be a spare sheet over here somewhere. Just grab one. And you can take my chair. So in this case, negative 3 on this side. I'll add 3 on both sides. So here we go, add 3 because that's a minus 3. And that gives me 8. So I'm going to write here plus 3 plus 3. Okay? So what does that mean? That means you've just figured out this equation that they wanted. They want you to find the equation of a line that's going to be parallel to this, as well as cross through 1, 5. So I've got y equals negative 3x plus 8. This must be the line. Let's test it. I'm now going to type it in Desmos. So the first line was negative 3x minus 5. So here we go. Let's go to Desmos. I'm going to change this. Y equals negative 3x minus 5. And let's zoom out. There we go. So that's the line that I have. I needed to figure out a second line that is going to be parallel, but at the same time cross through the point 1, 5. I'm going to label it. So I need this other line that crosses through 1, 5, but never touches this green line. Okay, so the one that we came up with was y equals negative 3x. Keeps it parallel, so we can see it's parallel, but it's not crossing through 1, 5. But through your algebra, you knew that if I had the correct rule, if I sub in 1, and then the result had to be 5, you figured out C was 8. So let's see if it's true. If I go plus 8, look at that. That is not by accident. That is us calculating what it should be. So it's like, you can put this in an application. You say, there's a comet that's going to arrive here by a certain time. If I shoot a rocket that goes in a straight line at a certain speed, how long before it hits, or where would it interject? You can actually predict what it would be, right? So this here, you can see it's parallel and it crosses through 1, 5. So if I zoom out, you can see the lines are always going to be parallel. And the only reason why that's the case is m is -3 because they're both the same. That's it. So what you just did there is an example that what you guys would do in Year 9 mainstream, Year 10 mainstream, and Year 11 mainstream, although we go through that much faster. Okay? That was it. So if you have to sketch it, we can already see y-intercept is at 8, 0, 8, and it's a -3x, and we just need to label the x-intercept, which we haven't got yet. But you guys can do that from exercise 1F. Okay? Cool as. Let's go next one. Let's do a parallel, a perpendicular one, and then we'll finish off today's lesson. That's it. Okay, so this is the same thing you're going to keep repeating. It's the same idea. Here we go. Same thing again. Find the equation of a line. As soon as you see that, you should be thinking of y equals mx plus c. That's the equation of a straight line. But they told you this time it is perpendicular. So that means this line that you're trying to figure out needs to be perpendicular to the first line. If it's perpendicular, what was the property again? Can I please have Nishi? Good. The property is m1 times m2 must equal to -1. m1 times m2 equals -1. This is the equation that we need to be perpendicular to. We can see that m is 2. So we know one of them is 2, then what must this second gradient be? What must this one be? If it needs to be perpendicular, if one is 2, then the other one must be? Yes, Samuel? -half. It's the reciprocal and it's the opposite sign, so we know that it needs to be -half. That tells me I now know it's -half x. The problem is I don't know what c is. But they told us that this line also passes through 2, 5. So what they're saying is, whatever this line is, whatever your rule that you come up with, when x is 2, you put it in, -half of 2 plus whatever this number is, it must equal to 5. Okay, so we're saying that when, based on this idea, that's your x and that's your y, when x is 2, y result must be 5. That allows us to solve for c because we've got all the other variables. So here, sub it in, you got 5 is equal to -half of 2 plus c. At year 11 level, obviously, it's not always going to work out nicely. That -half of 2 gives you a nice whole number. You can get fractions, and that's why you need to be good with fractions too. So sometimes it could be surds, it could be fractions. You've got to learn to rearrange it to get c. So here, -half times 2, we know that's -1. So -1 plus c is meant to equal to 5. And then from here to find c, do the opposite of -1. Add 1 on both sides. C equals 6. So what does that mean? You figured out that the equation needs to be -half x plus 6 to guarantee that this is going to be perpendicular to 2x plus 3, but also pass through to 5. So far, so easy. So today is exactly the same as what you did previously. In fact, it might even be quicker because you don't have to do y2 minus y1, x2 minus x1. That's what you were doing previously. This one's meant to be quicker. But funny enough, if I were to put this in a test and an exam for a 9 mainstream and 10 mainstream, they will skip this question and they'll do the other one. The other one takes longer. The other one is, to me, more tedious. This one, you just need to know the properties. Okay, so at year 11, they just did their quiz, and I'm going to put something similar to this for their SAC as well. It's just about them understanding the two properties. Cool? All right, I'm going to stop the video there.